Hey everybody, welcome back. If you liked the first video, you'll be back. If not, you might not be watching this, which is totally fine too. So in the last video, we kind of set the stage for what Venn diagrams look like and how they tie to logical statements. So I've left up if P, then Q to start with. Last video we talked about the contrapositive, which is true, assuming this is true. What we're going to look at now is the inverse, and you may have gotten through the inverse truth table and maybe been happy with it. But if you weren't happy with it, maybe that's why you're here. And I want to use this Venn diagram to show you why the inverse doesn't make sense. And I'm going to use that cat example again, I think, which is a good one. So the original statement is if P, then Q. The inverse is if not P, then not Q. Okay, so the difference, you might look at this quickly and say, that looks like the contrapositive. But the contrapositive, remember, these were switched. This one literally just takes the opposite of P and opposite of Q and leaves it the same. Okay, so if we assume that's true, we look here. And we knew why it was true before, because if you're in this circle, then you are definitely in this rectangle. The entire circle is contained within the rectangle. Okay. But this one says, what if you're not in the circle? What if you're not in this circle? What this statement says is, if you're not in the circle, then you're also not in the rectangle. Now you can see that's not true, because it might be true. For example, if you're not in the circle, you might be way over here, in which case you're not in the rectangle, right? But if you're not in the circle, you could also be right here, which means you are in the rectangle. So since it's sometimes true and sometimes false, we say it's always false. Things can't be half true and half false. Logically, they have to be always true or always false. Looking at the cat example, if this is all cats, let's change the color here. If this is all cats, and this is Persians, Persian cats, not Persian cats. If the statement is, if you're a Persian cat, then you're a cat, that's entirely true. The inverse of that would be, if you're not a Persian cat, then you're not a cat. Again, that might be true. If you're not a Persian cat, you could be an elk hair caddis fishing fly, in which case you're not a cat. But if you're not a Persian cat, you might also be a tabby cat, which is a cat. So just because you're not in here doesn't mean you're not in here. It's sometimes true, which would mean it's not logically true at all. So that's why the inverse is not logically equivalent to the original statement. And if you like Venn diagrams, I've offered you an extra credit on this project to look at the converse also. So the converse is what happens if you take the P and the Q and simply switch them. And I encourage you to look further at the converse using Venn diagrams. If you like Venn diagrams, you can also just use truth tables. Whatever's easier for you, whatever makes more sense to you. Either one will help you understand why neither the converse nor inverse are logically equivalent to that. Although the contrapositive is like the goofiest one of all of them. It's the only one that's logically equivalent up there. Okay, I hope that made sense, and I guess have it the rest of the project. You get to look at my bike headlights next, which is actually kind of fun. See you in class.